Hey guys, welcome to the BlockHeads Intro to Near Blockchain App Development Workshop. Hope you guys are excited because in this part we're going to be working through a hands-on project that's going to lock in all the core concepts you need to begin developing your own cool blockchain applications. If you guys haven't done so already, I encourage you guys to go check out part 1 because this project is designed to cover all the core concepts I went over in that part. But enough of this intro, I say we just jump right in and get started. I'm going to give you guys a quick overview of what we're going to be building. So this is what I like to call block view. Block view will be an application that will show your near blockchain information, as in your near token balance, the current block height, as well as the access keys, both full access and function call access keys, and a bit more. I'm going to log in right now and show you guys what we can do with this application. Through this process, I'm going to show you guys how to request full access through a third-party application to your near wallet. And when you log in, you're going to see all this information being displayed right here in front of you. So you have all your function call access keys, your full access keys, as well as your metadata for your account. So we can show you guys how to pull all of this information. I'm going to show you guys how to read your near balance, and then I'm also going to show you guys how to send near tokens to another user, as well as record the transaction histories and the total amount of near tokens that you've sent a particular user on the blockchain. So this project will show you guys how to interact with the near blockchain, making contract calls, both view methods and change methods. So we're going to cover all of this, and this should just be the core basic tools you need to begin developing your own blockchain applications. I should note that I used react.js to design this application in an effort to stick to a more component-based design for the tools you see here on screen. I also use React Bootstrap as a design library to cut out the fat and save on time in terms of styling, so we can focus on learning and understanding the tools that Near provides to create blockchain applications. So if you aren't familiar with React.js, that's totally alright. I'll put a link to a description to a crash course by Traversy Media. So now I want you guys to head over to Node.js' website and download the recommended version of Node.js in reference to the operating system you are using. At this point in time, the recommended download for macOS, which is the OS I'm currently running, is 14.15.1. It may be different for you by the time you watch this video if you're running on Windows. This will come with the npm package manager, which we'll use multiple times for this video to download various packages from React Bootstrap, Near Protocol, and more. Of course, during your own project and app development, you can use whichever text editor you're most comfortable with. However, to best follow along with this tutorial, I recommend downloading the Visual Studio Code text editor. So head on over to code.visualstudio.com and hit the download button and follow the on-screen instructions, and you just select all the default options to set up VS Code on your computer so you can move on with the tutorial. It's time to download the Near CLI as well as the Create Near App starting template to begin our app development. So we want you guys to head over to near.org and click on Docs. And in the search tool above, I want you to search for Near CLI. Then follow the on-screen instructions in respect to the operating system you're currently running on. So for Mac and Windows and Linux, you can just simply copy this line, paste into your terminal, depending on which terminal you prefer, after you've installed npm and node, which you've already completed. Or if you're running on Windows, you do have to go through this extra step of downloading the Windows subsystem for Linux. So just click on this link here and follow the instructions on this page. Once you've completed that, simply head back and copy this line and paste it into your terminal, again, since you've already downloaded npm and node.js. And there you go, you should have the Near CLI downloaded. So the reason why we're downloading the Near CLI is because it essentially acts as a wrapper for the Near API JS package, which can assist developers with testing by creating contract calls, running npm scripts, and doing more, all from your terminal. This will allow you direct control over the Near API JS, so you can quickly test things that you cannot do in your normal app development or your normal JavaScript development. So I'll show you guys a few of these tools here throughout the rest of this video, so just sit tight and you'll see where this will come up a little bit later. So here I am on the npm page for Create Near App, where they go over the usage installation on how to run or install a Create Near App. Of course, you can install this locally using npm, or you can run npx and just execute the node package right on the spot, which is what we're going to do. So in your terminal or in VS Code, in the VS Code terminal, navigate to the directory of which you'd like to store this project, and then run npx create near app dash dash front end equal to react. And then we're going to name the application block view. Okay, so once this is installed, we're going to type in, with my little face, we're going to type in code dot to open up VS Code in the directory that we created block view in. If you hit Command J on Mac, you open up your terminal within VS Code and just navigate into the file you just created. And to ensure that everything's working properly, type in yarn dev to run the development server. So build up the application, execute the development account. You can see that the development server is on localhost 57311. And once it builds, it'll automatically open that in your browser. And this will let you know that you have successfully ran create new app and started your app. I'll show you guys another way just to run create new app just through VS Code to make it a little more clear and direct. So I'm going to click open and go over to the folder that I created that I want to store block view in. So I'm going to go to documents. Here we go. Put in here. And if you hit Command J, you're going to open up the terminal down here. You can just run npx create near app dash dash front end is equal to react, the name of the project, which would be block view. And run through all the installation processes, download the node module packages and more. There we go, it says happy hacking, and we have our little file here that stores our React project. So you can just navigate to that file by typing in cd block view. Then again, just run yarn dev to make sure everything's working. Great, so we have our application nice and running. So now that you've run create new app and you have run yarn dev, you should see this example application appear, which lets you know that you've installed everything correctly and you're doing everything right. But now it's time to kind of clear out all of the example application text out of our project so we can have a clean slate and start everything from scratch. So we're going to go to source and then app.js and go up to this first curly brace and just delete everything below it. Replace that ending curly brace that you deleted and type in return parentheses p tag hello world. Hit save, and the development server should rebuild automatically. And there you go, you should see hello world right here. So now it's time to get rid of the styling for that page. So go to global.css in the same source file, hit Command A or Control A if you're on Windows, and hit delete. Put a star here, and next to that star, type in a curly brace, type in margin 0, and padding 0. And be sure to put a semicolon at the end of these lines. Go back to the browser, you should see a white background and the hello world nice and tucked in the upper left hand corner. So that got rid of our app, that got rid of our page content and our styling. It's now time to clear out our contract so we can have a blank slate to write our own contract calls and communicate with the near blockchain. So go to the contract folder and then go to assembly. Inside of assembly, go to index.ts and then delete everything underneath this import statement. And then just delete all these comments up here because I don't really need those. Hit save and go back to utils.js and select set greeting and get rid of it, and get rid of the get greeting as well. These items were in the view methods and change methods arrays, so just get rid of these two contract call names. I'm going to explain more about what that actually means later. And we're also going to get rid of this the contents of this request sign in method here. So reason why we're getting rid of like the contents within these parentheses is to tell our application that we want this third application to request full access to our near wallet. If you have this name here, it's going to set the configuration for your login and for your application only to request for a function call level access, meaning that you won't be able to send near tokens to other users or to another account. So again, we are doing this so we are able to send near tokens to another user and have access to our near tokens. This is like, it's not something you want to do for all your applications, but for now, it's okay. And that takes care of the cleanup. So now we've cleared out our create near app starting template. I think it's a good idea to head over to React Bootstrap's main website, install and download React Bootstrap into our project. We're gonna do this so we don't have to worry about any of the styling components. We can keep our bulk of our focus on the near blockchain tools that we have at hand. So head back to VS Code and hit Control-C and go back over to React Bootstrap and click on the Get Started button and copy this first line here. So we hit Control-C to stop the development server, and once you stop the development server, hit Command-V or Control-V, depending on which OS you're running on, hit Enter to install React Bootstrap into your Node Modules folder. While that's downloading, head over to your source file and create a new folder called SCSS. Inside that folder, create a file called app.styles.scss. So we're not going to be using too much of Sass custom stylings in our project. So if you don't know Sass, that's perfectly okay. Mostly what we're going to do with it is just import our Bootstrap stylings, but past that, you don't have to. We're not going to use it too much in this project. So with that said, head over to the Sass section of the intro page and then hit copy to copy this import statement here and paste it into your app.styles.scss file you just created and hit save. Go back to app.js and we're going to import that file we just created. So import ./scss/app.styles.scss. And to make sure that this works, we're going to go over to our React Bootstrap page, click on components, go down to NavBar. So we're going to both test this out and also kind of make progress towards our first step of creating our application. So look for this example here at the very bottom with this cool dark styling and these cool buttons, and just kind of copy everything you see here and go back into our app.js file and paste this in. To get this to work, we're going to need to import a few items from here from the React Bootstrap Node Modules package. So import curly brace NavBar. Well, there we go. But NavBar, nav drop down, and nav from React, in quotation marks, React Bootstrap. Hit save and then restart the development server to see if this all works out. Okay, so everything looks like it's working properly. We have our NavBar example running perfectly, and yeah, it all looks good. Great job, guys. So now we have our styling working, we have our NavBar imported, or at least the NavBar example imported. So I think it'd be a good time to kind of rework this NavBar example into something that works better with our application. So let's go over to React Bootstrap, or this line that says React Bootstrap here, and delete the name React Bootstrap and replace it with block view. We're also going to get rid of a few lines here, so we don't need any of these drop-down items or this drop-down section in general. So let's just get rid of it all. So nav drop-down. Get rid of these two nav links here. Get rid of this line that says more deets. And just replace this line here with the text login for now. So login. Hit save. And we're going to get rid of this href statement as well because I don't want to be redirected anywhere when we actually deploy this application. And we're also going to get rid of href home and this event key because we don't really need it. So hit save, go back to your browser, and then you should see where it just says login and block view. So now I think it would be a good time to actually add some functionality to this login button, because right now it doesn't really do anything. So I'm going to bring you guys' attention to one quick thing. If I type in window.account ID, you see I get this empty string here. That means like I'm not currently logged in with my wallet account. And why am I bringing this to your attention? Well, this is gonna make sense in about 2 seconds.
2 hours later.
But if I go over to utils.js and look at where window.account ID is actually defined, which is in, again, utils.js, you're gonna see it's defined to this thing where it says windows.walletconnection.getAccountID. So when you're logged in with your wallet account, that's actually going to return a string of the name of the account that you're logged in with. So if I go to wallet.testnet.near.org and I'm logged in, I should return a string that says blockheads.testnet. So let's see if we can get that to work. So I'm going to go over to app.js, go over to this nav link here and type in onClick. I'm going to use a ternary conditional operator to kind of define which function we want to actually run between the choices of login and logout. So I'm going to say if window.account ID is equal to an empty string. Again, we saw that empty string a little bit earlier, telling us that we're not logged in, not currently logged into our application. So again, if we get this empty string, we're going to run the login function so we can log in to our application. Otherwise, log out. Very straightforward. So here we're going to replace this login string with some JSX and say window.accountID is equal to an empty string. So same thing. We're just going to return what actually displays here when we're logged in or logged out. So again, once we get the empty string, if we're not currently logged in, we want to prompt the user with the option to log in. So we're going to say log in. So this is what's going to display when we're not logged in, if we get this empty string back. Otherwise, if we are logged in, we want to actually display the name of our account. So we're going to type in window.accountID. So that's just going to return the string, the string of the wallet account that we're currently logged in with. So we're going to hit save on that. Go back to our application. Right, click on login again. And it's going to redirect us to wallet.testnet.near.org, requesting full access. Now remember, it's requesting full access because inside of our utils.js file, earlier we replaced what was previously inside of these parentheses with now an empty string. So be sure to do that to grant or to configure your application to request full access to your wallet account so you can send and receive, or you can send off near tokens. So hit allow and type in the name of your account. So say confirm, and there we go. We can actually see that string being returned into our NavBar. So you can see the name of our account, showing us that we are currently logged in with this account. And again, if you type in window.account ID, you can already see that we are returning just a string of that account. And there we go, we have a functioning login button. So now we have the NavBar out of the way. I just want to say the bulk of our application depends on whether or not the user is currently logged in. If they're logged in, we can actually display the contents of our application, which would be the account state, their metadata, and their keys. If they're logged out, I want to create a message for the user prompting them to log in. So I'm going to first wrap our entire application in a React fragment. So take this ending tag and move it down here. This is so we don't have to necessarily wrap it in a div. So hit save. Below the navbar, I'm going to create another conditional statement depending on, and that's going to like check if we are currently logged in or not. So we're going to say window.accountID is equal to an empty string, I'm sorry, is not equal to an empty string. So meaning like if we are currently logged in, right, if we're not equal to an empty string, they're going to display the contents of our application. So we're going to call for a container. And a container comes from the React Bootstrap package that we installed. So we have to import a container from React Bootstrap, as well as a row and a column. Let's get that out of the way first. And then the first row inside of our container will be the place where we store our metadata. And you're gonna see me write this next thing quite frequently for every row we have. So I'm gonna call in class name and import the dflex class as well as the justify content center class. So again, class name is just how you import classes, just like you would from any CSS file. You can actually use class name to import import classes from CSS files. In this case, these are configured and written by React Bootstrap. So this is like, so dflex is like display flex, or you're setting the display to a flex box, and justify content center will center the contents of this row to the center of that row. So this is something I'm going to be typing very frequently, so just kind of get used to that for now. So moving forward, so we have our first row out of the way. Our next row, we will have a column. Actually, we don't need this. Yeah, okay. Wait. So for our next row, we're going to, this will be the place we're gonna actually house our place we're gonna send the tokens out, or our feature that sends tokens out. So I'm gonna type in send token out as a placeholder. So metadata and send token out will be our placeholders. And then we can move on to the next row where we will have our active keys. So row active keys. We have send token out, active keys, and the metadata placeholders. These will be our primary contents for our application. So we're gonna have to write our alternative display option if the user is not currently logged in. So what we're going to do is type in a colon here. So that's going to signify the quote unquote else statement for our conditional statement that we wrote here. And as the alternative to not being logged in, I'm actually gonna move this one line lower. As the alternative for not being logged in, we're gonna prompt the user with a message to ask them politely to log in. So we're going to call for a card from React Bootstrap again. So we're gonna import a card from React Bootstrap. And inside this card, we're gonna have a card header. And I'm going to say hello user. And we're going to add some text styling to this by saying AS is equal to H5. So that again comes from React Bootstrap. And then we're going to create a card body to define the body of this card. And again, we're going to create another card title. Card.title. We're going to say please log in. And then card.text. This application. Oops, cannot spell. There you go. Application will not work otherwise. And then maybe something sassy like sorry, not sorry. A little smiley face. And then we're going to create a button below this text that will like the user can click on to log in, just to give them another option, just in case if they don't immediately see the login button in the upper right hand corner. So button on click is equal to login. So again, this is how you get the user to navigate to get redirected to the wallet to log into your account. That's pre-made for us with the inside of the utils.js file when we run create new app. So the button will have the contents login now, just make it very bold and very clear. And I think that's it. So if I hit save, we should rebuild the file, and we're gonna go back to our application, and you can see our placeholders when I'm logged in, so that's good. So you can see metadata, send tokens out, and active keys. These other items aren't centered because we don't have this class name on the other rows, so let's just copy and paste this class name here in the first row where it says send tokens out, and here where it says active keys. So save, and then those should center immediately, so that's pretty good. If we hit the logout button, it says buttons not defined, so we're gonna go back up here because I did forget to import button. So button, save, go back. So we can see this card appear here, prompting the user to log in. So it's saying, hello user, please log in. This application will not work otherwise, sorry not sorry. Hit the login now button, which you get redirected to the Near wallet, asking for full access to the third-party application and our wallet, or from the third-party application to our wallet, so we can send Near tokens, hit allow, type in BlockHeads.testnet, and oops. And there we go. We're back to our placeholders. So yeah, there we go. We have our login, logout restriction feature set up. So the first component I want to create will be the metadata component. So to replace our little filler text that we have here. Before we do that, I want to show you guys the type of information we're going to populate the metadata component with. And to accomplish that, I'm actually going to show off a feature of the Near CLI tool that we downloaded earlier. So if we go to your terminal and type, Control-C to stop your development server from running, type in Near, and then like a whole slew of options will appear for you to use with the Near CLI tool. So remember, the Near CLI tool is just a wrapper for the Near API.js, meaning that like anything you can do with Near API.js, you can do with the CLI tool straight from your terminal. So if you type in Near state in single quotation marks your account name, so my account name is BlockHeads.testnet, you will see the state of that account. So that will display the amount of Near tokens you have displayed in Near, which is about 10 to the negative 24th. Your locked tokens, your code hash, and this code hash is all ones, meaning that currently for this account named BlockHeads.testnet, it has no contract deployed onto it. And what that means is that like so whenever you create an application or you ever deploy a contract, that contract has to live somewhere on the blockchain. So traditionally what happens is that a dev account is created, meaning like a temporary account, not a temporary account, but kind of like a placeholder account is created to act as the quote unquote home for that contract. So when this is all ones, it signifies that there's no contract deployed to this account. So this account has no contract on it. Every time you deploy create Near app to start your development server or to make it live, create Near app will automatically create a new dev account for you. So you can even see that by going to Near dev and clicking on dev account, and that is my dev account that actually holds this contract. I can even copy this dev account and type in Near state single quotes, paste, close quote, and then get the state of this dev account. So this is an actual account. It's no different than this one up here, the one we created on wallet.testnet. It's just an account that's automatically generated when you run create Near app and yarn dev. So here's the code hash for this particular contract that exists on this account. Moving forward, we can even see the storage usage from this account, the storage paid at, the block height for this of which this account lives, or like of which we're currently acting upon, and then the block hash and the formatted amount of this Yocto Near, this amount that's being displayed right here. So this is just what you would normally see on, say, Near.wallet.testnet, the like 500 Near tokens that you automatically see there. So that is essentially the information we're going to display in our metadata. So moving forward, what I want to do is create a new folder in source, a new folder called components. Inside this components folder, I'm gonna create a new file called metadata with a capital M .js. So I'm gonna make another little tangent here. What I recommend you guys to download, you don't have to, it's just a preference thing, but I love using this react.js code snippets by Charalampos. It saves you some time it's like essentially a library of shortcuts that you just type in, hit tab, and then like a starting template for whatever you want to create will appear. To show you an example, I'm just going to go back over to the metadata.js file we just created and type in rcsp, hit tab, and there we go. We have our starting template for this metadata function-based functional component. So if you don't have it yet, just like copy this down. It's fine. Just pause the video and then we can move forward from there. I just wanted to show you guys that because I think it's kind of cool. So I'm going to get rid of this metadata.prop types because I don't really need it, and then get rid of line 2 here because again I don't really need the prop types. I'm going to then import use state and use effect from React, and then I'm going to also import a table from React Bootstrap. So this table will be used to actually hold and house the metadata. So the first thing I want to create is a place to store the data. So I'll create a state variable right around here. Okay, and let's call the initial variable constant. Let's call the initial variable just metadata. And then let's call the change variable or change method change metadata. Then let's set the initial value of the state variable with useState to an empty object. So we're gonna use an object to store and execute our data essentially. So now after this, what I want to do is call the useEffect method or React hook to create an asynchronous function that will go and retrieve our data. So we're going to initially call a callback function to initiate this new function we're creating. So we're going to say callback function will then create this asynchronous function, which we're calling getData. And inside getData, we're going to define a variable called data, which will await for the data to be retrieved from the blockchain. And let's see, we can immediately see this data take place into our terminal once we retrieve it, just to make sure we are getting the correct thing. Then after we have our data, we're going to use the change method that we created called change metadata to replace that empty object with the newly retrieved data. And this will all happen on the very first instance of upon the component loading onto the screen. So now we have our function created. This function will not execute unless we actually call the function. So within this useEffect React hook, we're going to call getData. And that's it. Before we can do anything, we actually have to define window.account because for now, as it currently stands, that just doesn't exist. So let's go over to utils.js, and just below window.account ID, I'm going to type in window.account and define it to be new account, and set the first argument to the near connection, near.connection. Near is defined up here to the connection method from the near API.js, and I'm directing that connection referencing that connection to the current account that is signed in to the application, which is defined by window.account ID. So we're going to just type in account ID. So now we're able to pull the state from this account object or account class and then get the actual metadata that we need. So now it's time to test this out. Before we do, I forgot to add the account. I forgot to actually pull the account object from the near API.js. So let's just add account to this first import statement we have here, just to make sure this works. So now we're going to save this, go over to app.js, and import that metadata component we just created. So import metadata from components, so ./components/metadata. And then we're going to go down to where we have our placeholder here and call metadata, and be sure to end it with a self-closing tag. So now down here in your terminal, if you haven't done so already, just run yarn dev and wait till the development server starts. Oh, and be sure to save this as well. So then the metadata line should disappear, which is a good thing because we don't have any JSX we're returning just yet. If you open up the inspection tool, you should see an object appear. Inside this object will be the account state data that we are looking for. So now we actually have the data, let's actually display it to the page. So let's utilize the table component we received from React Bootstrap on line 2 and utilize that to initiate our table. So table, there we go. And kind of follow along with me with the properties I'm going to design the table with. These are just properties you can find on React Bootstrap's website. So these are just designed elements. So striped, bordered, hover, variant is equal to dark. And there we go. Now let's actually populate the table with the data we have from our data hook or data component or variable. So we're going to start with the head of the table to actually define our columns. So we're going to say t head and define a row, so tr, like table row, with th, the first column being called data title, and then the next column being the table or the data value. So we're just going to call that value. Then after t-head, we're actually going to start working on the body of the table where we actually house our data. So we're going to say t-body, and then we're going to define the first row, tr, with the amount of near tokens we have. So td amount. Then next will be td, that's going to be the name of the value, so that's the data title. And then the actual value itself will be metadata dot amount. So let's just again say what's happening here. So we have metadata being defined as data, which is the result of the window.account state that we called earlier. So we're just calling the amount property from the state. And then that is essentially it. So now this is going to get a bit repetitive, so just kind of bear with me for a minute. But I'm going to take this line and just duplicate it. Oops. So let's actually bring that down. There we go. And then over here, we're going to call this next row the locked token, so locked. Then we're going to switch amount to locked. Then take that. I'm not doing well with this. Okay, here we go. Take this line and just duplicate it again. And I think it should be fine. Okay. So the next locked row we're going to call code hash. Then we're going to pull the code hash from the metadata. So code underscore hash. Then this next line will be the storage usage. Then we're going to say metadata.storage underscore usage. Then this next line will be storage paid at. And then the property we'll be pulling, of course, will be called storage underscore paid underscore at. And duplicate this line again. And we're going to do that one more time. So we're going to call this next title block height. And then this last title will be called block hash. And of course, the properties will be named as such. So block underscore height and block underscore hash. So let's save this. See if we get any errors. It looks like we have one error. I think I just misspelled. I added some weird character to the table. So save that again. Okay, so now it's successfully built. So let's go back over to our application, and there we go. It seems we're missing the locked amount. So let's just see. I might have mistyped something. This has to be lowercase. There we go. Okay. So now we actually have our metadata component displaying the data for the account that we're logged in with. So I'm going to do my best to keep the custom CSS to a minimum, but I want to kind of separate this data table from the top NavBar. So what we're going to do is just going to go to this div and say style is equal to double curly braces and margin top 10%. Let's just see how that looks. And 10% has to be a string. So let's rewrite that to be 10%. Save. And there we go. That's a good enough gap for now. I might actually make that 5, but let's see what 5 looks like. There we go. I think that's a good enough gap. Anyway, just wanted to throw that in there. So now we created our metadata component.
What the man demanded that the chip? What the man demanded that the chip as a response to allegations. I'm sorry, I seem to have something stuck in my...
It's time for us to build our send token feature. This will allow us to send tokens to another user, and we even incorporate creating a smart contract that will help us keep track of the total tokens we've sent up to a particular user. So hopefully this will be good in showing you guys the workflow that's commonly associated with creating a smart contract using assembly script. So with that, let's jump in and get started. So let's go over to app.js. Actually, let's go over to source file and create a new file in the components folder called sendTokens.js. Inside this file, we're going to call rcsp using React snippets to create this kind of starting template for a functional based component. And we're going to start off by creating some state variables to keep track of our recipients and our values sent, as well as our current balance for our tokens. So const recipients, and I'll show you guys why we're making a recipients array in a minute. Essentially just like be related to the smart contracts. So recipients set recipients as our state variable. It's equal to use state. So let's call this from React because I feel like I haven't done that yet. So let's call both use state and use effect. There we go. Our initial value for recipients will just be an empty array. Our next state variable will be another array called values sent. Then the change method will be called set values. And we're going to say the initial value for this will be another empty array. Our next line will be const balance change balance, and initial value for this would just be 0. So now we're gonna return from our contract call, and we're gonna actually store in the blockchain as well through all these interactions. Will be an array of strings for our recipients and an array of values corresponding to the indexes of each recipient. And then, of course, we just have the balances you're pulling from the blockchain per our account. So let's head on over to the contract code to actually define the contract that these variables will be based off of. That will essentially run our ability to keep track of the totals we've sent to particular individuals from this account that the user signed in with. So let's go over to contract, assembly, and then index.ts, where under the import statement, we're going to define 2 variables. So the first variable will be const recipient list is equal to new, and again, remember all this is written in TypeScript or assembly script, which is a dialect of TypeScript. So things might be a little bit different, but they aren't too far off from JavaScript. Just keep that in mind that we're not in JavaScript right now, we're in TypeScript, or assembly script, either one. So we're also going to, for continuous statement, we're also going to import a persistent map from the near SDK and implement that here. So for this first persistent map, we're gonna say each key for this map will be a string, and it will give access to an array of strings. Then we'll give it some unique identifier. We'll call this RL for recipient list. And then the next variable will be const total sent, which is equal to new persistent map. The keys will be defined as strings, and then the value will hold will be an array of type i32 numbers. So, and then the unique identifier will be TS. So I know this is a little bit confusing, so let's go over what these persistent maps even are and what the heck I just wrote. So a persistent map is a data structure that is included in the near SDK. It can be essentially thought of as a dictionary like you would find in Python, or even an object that you find in JavaScript, in which each different key gives you access to some sort of data type. So this first parameter we have here, this first string we have here in both lines, is the data type for the key. So I'm defining the string. I'm defining each key as a string, and then what this string gives you access to will be an array of strings. That's why I have string with this little bracket here. That's a TypeScript or assembly script identifier for an array. So I'm specifying the data types that will exist in this array. In this case, it's an array of strings. In this case, it's an array of type i32 numbers. And then this last argument we have here is simply just a unique identifier for each of these persistent maps to avoid data collisions within this contract. So these are just simply, these have to be unique for each different persistent map you create for this contract, just so you can avoid data collisions and keep things nice and straight. Moving on, I'm going to define our very first function, which I'm going to call add funds. So export function add funds. So this export statement here allows me to actually access this as a public function. So that way I can export it to the utils.js file, which will define it as either a change method or a view method to then be used in a practical application. So the first argument for add funds will be a recipient, which will be a string, and then amount, which will be defined as an i32 number. And then this function will return nothing. So we're going to return void to denote that we return nothing. So it's denoted by this colon followed by the word void to return nothing. So if we're going to check for is if the recipient list contains dot contains. So all of these methods I'm pulling out, like recipient list dot contains, can be found on the near documentation for persistent map. So I'll be sure to include that in the description for you. So if it contains context.sender, so that means the current signer of this account. Keep in mind that this context.sender only works for change methods. It does not work for view methods. But what essentially this will return is the name of the user that's initiating this transaction, that's sending off this transaction with the blockchain. In other words, this will just return a string that says blockheads.testnet. So you can just imagine this just being blockheads.testnet or your account name, whoever signed in to your account or to this application. So if this contains the name of the person that's signing this transaction, then let's create a variable get list, which is equal to recipient list dot get some context.sender. So I'm using the name of the person who's sending this account as the key. So since this will return a string, that string being the name of the account, I am retrieving the list of names and then also the list of values of the people I've sent money to. In other words, so recipient list.getSum for blockheads.testnet will return a list of names, which will all be strings, of every single person I've ever sent money to. And then the same thing for this value, a string or the key being my account name will return the value types that correspond with each name or each person I sent this money to. So let's also retrieve the totals. So get totals is equal to total sent dot get sum context.sender. So what am I doing here? I'm like, this conditional statement is just making sure that like I previously sent someone some money in the past. It's making sure that this value even exists. If it doesn't exist within this map, then we'll have to create an else statement that will create a new list for this new user. But if it does exist within this map, then they must have some existing or some previous transaction that exists that we're going to pull that data from. So it'll make more sense when I'm completed with this. So if get list dot includes recipient, then we'll do some action. We're going to say let get index is equal to get list index of recipient, and let old total is equal to get totals get totals bracket get index. So I'm going to pause here for a minute and just explain what's happening again. So get index is equal to get list dot index of recipient list. I'm essentially kind of doing the same thing that I was doing up here with this first conditional statement. I am making sure that this recipient exists within this list of names of people I have previously sent money to. Hopefully that makes sense. Essentially, I'm just checking that out of the people that like Dorian has sent money to, I have let's just say this person was Bob. Like I have previously sent Bob some sort of money, and Bob is in my list. And I'm using includes because get list is an array. It's just an array of strings. So I'm using the index of this list, of this name list, to retrieve the value I've previously sent this person. So the values index should correspond with the name with the name of the person who have received that value in these two lists. So new total is equal to old total plus amount. So I'm retrieving the total money I've sent them before. Let's say that money was like $10, and I am adding the amount of tokens that I am currently sending them to the old total, so I can keep track of that total of the total overall value I've sent this person. So get totals is index of that will be get index is equal to new total. So now I'm just updating that list of values to update the total money sent to that user. So totals, total sent dot set context dot sender. Again, that's just my name, my account name. This dot set is setting a new value or updating an existing value in this persistent map. Get totals. So now I am essentially just replacing the old array of numbers that existed here with this new updated array of numbers. So that's what the get totals is. It's just an array of numbers. Moving on. So if this list does not include that recipient's name, then we're going to say get list, which again is just an array of names, array of strings. Get list dot push, we're adding a new recipient to that list. Recipient list dot set context dot sender get list. So what am I doing? I'm just simply updating the existing list of recipients with this new list of recipients for the recipient list persistent map. Get totals, doing the same thing for get totals. So dot push amount. So setting a new amount, setting a new item to the get totals list, of course with the indexes for both the name and the get totals list being the same, with this new amount that we're initially sending them. So now total sent dot set context dot sender get totals. So now we only have one more conditional statement to worry about. Else, there we go. It's accounting for the case that the user has never made a transaction before. So meaning that the person who's currently signed in has never even made a single transaction with anyone else before. So let's cover that scenario by saying if the user does not exist within this list, let's let recipient list dot set this new user, this context dot sender, with his very first transaction. So we're just gonna just directly put an array of strings. So it'll be recipient. And we're going to do the same thing for his very first value. So we're going to say total sent dot set context dot sender dot amount. So there we go. This is our very first contract call, our very first contract function. So we're going to take the name add funds. So go ahead and copy this name. Remember, we're adding things to the blockchain. We're adding new values, new names, new everything to the blockchain. So when we go over to utils.js, we want to, we're effectively changing the state of the blockchain. So we're going to add this as a change method. So add funds. If we were just reading some sort of value from this, we would simply put as a view method, but we were adding it as a change method. Something I want to reiterate is that context.sender only works with change methods. It does not work for view methods, so do not design your contract calls using context.sender if you plan to only read some data from that. But that's something I just learned. So let's essentially save this. So we're saving our index.ts. You can test if this works by going back to our application and opening up the terminal and typing in window.contract.add funds. And let's just say, you know what? And one more thing before I even execute this function, let's just add a logging log saying logging log saying user exists within list updating values or updating lists. And then we'll say for this else statement, let's just say logging log, which is essentially the equivalent of console.log. So logging log, user does not exist within storage, adding new user. So save that, head back over here, so adding funds. Our first parameter is recipient, and our second parameter is amount. So whenever you create a contract call, you want to your arguments or your parameters will always be an object. The properties of that object instance will be the names of the parameters you defined in your contract. So recipient, say recipient was just test1, and the amount will be, I don't know, 10. Just say 10 for now. And every contract call you create is asynchronous, so you have to type await in front of it so you can actually read the readout inside of your terminal. But only put await when you're inside the terminal. I mean, you will have to do this inside JavaScript as well, but for now when you're testing the terminal, just remember to put await in front of your contract call. So let's hit enter and see if this actually works. Ooh, so contract method's not found. Maybe this didn't load properly. So let's make sure we have everything correct. So save, Control C, yarn dev. Let's try this again. So user does not exist within storage, adding a new user. So that effectively does let us know that it actually went through our function and added this new user. Keep pushing, and we're going to find a way to display this data onto our new component. So now let's actually construct a way to receive these list of names and these list of values from the two persistent maps that we created. So we're going to create a new function inside of the index.ts file for our contract, which we're going to write as export function get names, in which the parameter will be called user. There we go. Which should be a string. And this get names function will return a string or an array of strings. So if recipient list contains the user that's signed in, so user, then we'll return the recipient list of that user. Let's see, and otherwise, if this person does not exist, or if this user has never sent a single transaction before, we're just going to return an empty array. So let's take this and actually copy it over and create the same function, but for the values instead, so values. So the parameter can remain the same, and instead of a string, we're going to return an array of type i32 numbers. So instead of recipient list, we will replace this with total sent. So save this, go over to utils.js, and inside view methods, we're going to write in get names as a string. Get names, and what was the other one? It was get values. So get values. So let's hit save. Let's make sure we save the index.ts, and let us stop the development server and rebuild it. We're going to call get names to get the names of the users that we've previously sent money. Right now what exists in there is, I believe, test1 from that first transaction we created. So window.contract.get names, Again, remember to put await before you type anything else. So user, right? So we're making an object instance with the parameter user, which we'll call window.accountID. So we can even type that folding out. So window.accountID. See if this actually works. So I'm going to hit enter, and there we go. Remember that window.accountID, if you're wondering, is simply the string blockheads.testnet. So if I were to type in blockheads.testnet in place of window.accountID here, then we'd still get this array of names, or yeah, which in this case is just test1. Otherwise, we can even type in get values. And I believe I sent them 10 near, or 10 quote near. And there we go. We have the value of 10 as our array, or in our array of values. So now we've defined and tested our lovely contract functions. I think it's time to actually implement them into our send money feature. So let's start off by building up the body
Said I'm about to catch a body in here, baby.
of that component. So what we're going to start off with is housing this entire thing, housing the entire output into a container. So container. Of course, we need to call that container. So I'm going to say import container. With every container comes a row and a column from React Bootstrap. So in this first row, we're going to create a card, or we're going to utilize the cards component from React Bootstrap. So we're also going to have to call card. Inside this card, we're going to have our card header. Inside the card header, we're going to say near token balance. So this would be a feature that the user will use to immediately see their balance displayed on screen, so they don't have to go back up to the metadata component and kind of fish through all those rows, even though it's, I think it's the first one. But still, it's just, anything to make it easier for the user. We're also going to pull another component from React Bootstrap called list group. And below card header, we're going to essentially call list group inside of list group. We're going to call a list group item, and let's make the variant for list group flush. Again, that's just a React Bootstrap design element, so flush. There we go. So here we're going to call, we're just going to essentially just leave this as a placeholder called near tokens, and come back to that and actually set up a way to format and properly display the near tokens we have available to the user to send off. But for now, that's a placeholder we're going to leave right there. So below card, we're going to, here we go, clear a row and start a new row. Where, actually I should have done this for the first row too. We're going to establish a class name for this row and just get this out of the way. So it'll be dflex and then justify content center. Again, this is just done to justify the content or to center the content within each row to make it nice and neat. So copy and paste that into the first row as well. So class name is equal to that. Great. So inside this next row, we're going to create another card. So card. Inside this card, we're going to have another card header. Card.header. Where we'll title this new card as send money to friend. So this is where we're actually going to place and organize the tool that will be used to send money to the user's friend. So card body. will actually house the features and the input fields for that tool. Inside card body, we're going to create a new container that'll help us organize our input fields and our submit button and our contract call area. So let's add a row. Inside this row, we're going to have 2 columns. So in the first column, so 1 column, 2 columns. So inside this first column, we're going to have 2 input fields. So input, I believe these are self-closing tags, so let's actually just self-close it and duplicate that. So we'll have the type as text and it's equal to text. And then the placeholder will be enter recipient here. So this first input field will be where we will enter the name of the person that's receiving money from our account. So type is equal to text. Placeholder will be enter value here. This will be where we'll input the value of how much money we're actually sending to that user. So in the second column, we're simply just going to have a button from React Bootstrap. Now we don't have to worry about the stylings of our own button. There we go. And actually have to call button from React Bootstrap, so let's get that out of the way. So button, there we go. And this would be our submit button. So we're just going to type in the word submit. And after we have our submit button written out, we're going to conclude that row and create one more row. So again, class name is equal to d-flex, justify content center. And inside this row, we're actually going to house our table that's going to display all of our previous transactions to the users and the total amount of tokens we've ever sent to that user. So this will be the results of our contract call. So table, let's add some styling to this. Style, double curly braces, margin top. And let's do 10px for now. 10px. Same thing as before, so striped, bordered, hover, variant is equal to dark. And conclude that. So inside our table, we're going to have a T head and a T row and TH. Column span will be 2. And we'll call this table transaction history. That's what we're going to actually name the table. So transaction history. That will conclude T head. Onto the body of the table. So T body. We're going to have this will actually be the place where we're actually going to output and display our recipients and our values. So we're actually going to come back to that a little bit later, but for now let's just put little placeholders perhaps. So let's say TR, and then TD. We'll say recipient 1, and then the next data field will be TD. Just do 100 near or 1000 near, just as a placeholder for when we actually come back to this and we can actually properly retrieve the data from our contract. So let's save this and let's go back to app.js and let's import send tokens from component slash send tokens. And we're going to find our placeholder send tokens out and just replace it with that newly imported component. Send tokens. Can make this a self-closing tag. There we go. So let's save that. Go back over to our browser. See if we have any errors. So tables not defined. Yes, I did forget to actually define tables. So let's go back into here and define tables. Or did I say tables? Table. There we go. And there we are. So we actually have a card that's going to hold our near balance, hold and display our near balance. And we actually have our tool here. That's going to be the place where we type in the recipient's name, just like this, and also the value of tokens they want to send them. And this should actually appear here. Again, this will be the total amount of value, or the total amount of tokens we've ever sent them. So this value will just get bigger and bigger every time we enter in a new value. So now we have the design of our send token feature laid out, as well as the table that will house our transaction history. Let's actually add some functionality to this, because right now it's doing a whole lot of nothing. So let's head back over to our sendTokens.js file and head up above the return statement below the state variables we created. And below the first state variable, we're going to define a function called sendGift, which will be an asynchronous function. So we're going to type in the word async here and define this as an arrow function. Inside this arrow function, we're going to start off with 3 more variables called, which we'll call getState, which will simply retrieve the state of the account that's currently logged in. So that will be used to actually display our balance. There we go. Next will be getAmount. So is equal to await window.utils.format near amount and get state dot amount, and let's see, there we go. No period right here. Okay, so get state dot amount, and this m should be lowercase. So before I move forward, I want to make sure that you guys in your utils file, in your utils.js file, you've defined windows.utils as utils, and you're successfully importing utils from near API.js. The reason why we're pulling this utils, again being defined here, into windows.utils, is because we need that formatting tool. So that formatting tool that comes with utils.js will take in Yocto near and format it out as a normal near amount that is easy for us to read. So essentially, instead of I can't even say it. Essentially, it'll take a very big number and reduce it to the amount that you normally commonly see onto the inside of your near wallet. So essentially, instead of this amount here, this crazy large, I can even say that full number. What that window.utils.format near amount will output will be 161.303, which is a lot easier to read than whatever this is. So moving forward, let's lowercase this m2. So moving forward, we're going to enter in a third variable called entered value. So entered value will actually call upon one of our references that we have yet to make. So let's make that right now. So let value input is equal to react.create ref, and let's create another one for the recipients. So recipient is equal to react.create ref So in normal vanilla JavaScript, you would normally interact with the DOM by calling some sort of ID and then interacting with that ID by saying, let's just say we're trying to get some value from like a text field. So you give that text field some sort of ID and then call that ID and then call the value within that text field of the value that the user typed and then do something with that data. So for react.js, this is the alternative way to do that. And for React hooks, where you have to use the createRef method or createRef hook that comes with React. Essentially what we're going to do is just retrieve that input and that data that the user enters into that text field. So we'll say value input is equal to, value input.current.value. Let's add a conditional statement that says if number get amount. So we're converting the result of this statement here to a number because I believe what we're going to get back is a string. So if this number is greater than the number of the entered values, or converting the number we enter into the input field from a string to an integer or a number, then we will execute the following. So await window.account.send money. So this is the built-in send money feature that comes from the near API JS from that account object that we established earlier. So right here on line 18. So going back to the component, so send money to the recipient, so taking in that value or the name of the person we're sending money to, and we will send them this many near tokens. We're going to say window.util.format.parse near amount entered value near amount. So this utils.format.parse near amount will take the entered near value and convert it into yocto near. So now, let's see. So moving on, we're going to add some then statements to this. So once that actually sends out, we're going to execute this next line that says await window.contract.add funds. So we're calling contract.add funds recipient, and let's just make sure we have that correct. So add funds, recipient, and amount. So recipient will be the recipient current value, and then the amount will be number entered value. So remember, we have to include this in an object instance. And we are converting this entered value into a number so that our function can actually read it and record it into the blockchain's storage or persistent map that we created. So once that actually gets sent off, we're going to wait until that's done. And if that properly executes, we're going to change the variables or update the values so they can update live on screen. We're going to say set recipients to await window contract.get names. Then after that, we're going to set the values. So set values to await window.contract get totals. And inside get names and get totals, we actually have to define the user, right? So make another object instance with the parameter user. Let's make sure make sure getting that correct. Yeah, so user. And the user's default value would be window.account ID. And we can copy this entire thing and paste it into here. So that's going to update these two variables with the newly added name and value of the person we just sent money to. So we're not done yet. We still have to we still have to create an instance or create a scenario in which this condition is not met. In other words, the value is higher than the balance. So we're going to say else alert not enough funds. And Near actually has built-in protections just in case a user does not exist. It will not execute the send money feature, so your money won't just vanish off into the void. You'll actually receive an error that lets you know that this Near count does not exist. And on top of that, it won't let you send more than you have, so on and so forth. So Near actually has these built-in protections for you, so you have to write all those errors out yourself. So moving forward, let's utilize the use effect React hook to call a callback function, and we're going to define another asynchronous function, which we're going to call getData again. So we're going to say async function getData, and getData will do the same thing as before. State, change balance to data.amount. So once the page loads, or once this balance feature changes, the balance will update on screen every time we reload the page. Of course, you have to actually call getData. There we go. Now let's create one more function to that's essentially going to get rid of a bunch of decimal places that we don't really need. Whenever we use the utils dot format near amount, we're going to end up with a lot of decimal places, about more than we want to read on screen. So this custom function we're going to create is just going to lob off the extra decimal places that we don't really want, and just have it to maybe 2 extra decimal places, just to make it easier for the user to read. So we're just going to create this quick custom function. So const format output is equal to text is equal to arrow function, so of text, which would be a string text if text dot includes a period, we will execute the following. So let ARR equals to text dot split by the period, and we're going to say array1 is equal to array1 dot split dot splice. I'm gonna do some crazy JavaScript magic here. Hopefully it's not too confusing. So essentially, I'm looking for a decimal, and then I'm going to split this this string up by an empty space, or not an empty space, but I'm even just no spaces at all, just by each adjacent letter or character. So I'm gonna say splice 0 0 comma 2 dot join. Splice was used to literally cut up and remove parts of an array, and then join is used to take an array of characters and squish them back into one single string. I'm going to say console.log. So we're going to actually display this array to see if this actually worked, and then return array.join. So otherwise, so else return the text that was originally inputted. So like if this does not include a period, then we're just going to return the text that we originally got. And we're going to use curly braces instead of parentheses. So save that. See if we get any errors. And let's actually go back to, I'm actually doing a lot hoping that this all kind of works. But like, let's go back into our return statement and actually add some functionality to our placeholders. Actually, we replace our placeholders with functional components. So we actually see this out all working. So let's start off with this button. This one's really easy. We just say on click. Oops, I can type on click. Is equal to send gift. So when we click the submit button, this entire function should run. For our input text fields, we actually need to establish our references. Let's do that right now. So ref is equal to recipient. Again, that's referencing this create ref we made up here. So we can actually pull the value from this input field. And we're going to add another ref to the second input field for value input. So hit save on that. Next thing we're going to do is we're going to actually populate our table body. So now this one's going to be a little tricky, and this one's going to be a little bit weird, but it's not going to be too bad. So we're going to delete our placeholder entirely. We don't need any of this. Inside our table body, we're going to create some curly braces. This will be a field for us to input some JSX. So we're going to call for recipients.map. And for every value of recipients, which is an array, we're going to cycle through each independent value, which we're going to define each independent value as X for now. And we're also retrieve the index of that value. So recipients is an array of strings that we receive from our contract. So, and this will cycle through each array of strings, temporarily assigning it to the variable X, while keeping track of the index of the person we are currently referencing. So we're going to return, so parentheses, a row for each value with a key of X so we don't get this thing screaming at us. And we're going to say the first data field will be TD, the name of the person, name of the recipient, and TD and we're going to input in the value of near tokens that we sent to this person in total. So we're going to say $, parentheses, or sorry, $, curly braces, value sent, and pull that index that we defined earlier. So this map function takes care of the correct index for us, and then close that curly brace and just type in the word near. So I'm using the little tick mark next to the left of the one button to be able to write strings like this. If you need to use quotation marks, go right ahead. Okay, so moving forward, I actually found the error that was plaguing our map function. So take that parentheses I just deleted and put it above this curly brace, and it should be working now. I also found another error where I have this as capital B instead of lowercase b for balance. That's not going to call anything. And there's one more thing we actually have to create. We have to actually establish another use effect into our application. Reason being is because we actually need to load in the name list and the value list when the component loads, so something can actually populate that transaction table without the need of setting up a value. Oh, and this get totals name is wrong. This should be get values. So be sure to change that to get values in the set values function of our send gift function. So inside of the second use effect, we're going to define another asynchronous function, which I'm going to call get transactions. So async function get transactions parentheses curly brace set recipients. We're going to call our change method. Inside of our change method, we're going to say await window.contract.get names, and we're going to actually just kind of copy this line we have up here because we're doing essentially the same thing. So I'm going to say copy, and let's find where the other use spec was. Copy and paste. And let's do the same thing for the set values. We don't need the .thens around it because we're not actually waiting for anything to conclude. But paste it right here. So now what we're doing is we're just setting the empty arrays with the popular arrays that exist on the blockchain under this account name. And this should happen when the page loads or when the component loads. So we're going to add a comma and an empty array right here. Of course, we're still not done. At the end of this get transactions functions, we still need to actually call get transactions because right now nothing's happening. So we're going to call get transactions right after this concludes, empty parentheses, and hit save. So everything should function. So if we go back to our application and look at our transaction history, we actually have X and 10. So X is wrong, probably because I forgot to put this in curly braces. So it's just reading this X as a string. So we're gonna add some curly braces in between these two JSX tags to implement some more JavaScript inside of our JSX. So just type in X inside this map function, inside curly braces, and it should work. So hit save, go back here. We have test 1, just to make sure this all works out properly. We can even try everything out here. I'm going to send my test account, so monkey123.testnet, and let's just send monkey3 near. So let's just see if this works. So we hit submit. And wow, there we go. Cool. So we have the name of our new recipient and a new total for that recipient. So if I send monkey.testnet, monkey123.testnet, let's just say 5 more near, we should see 8 appear here. So hit submit. Wait a second. And hopefully we see 8 appear here. And there we go. Yeah, we even get our cool blockchain receipts from the near blockchain, letting us know that this actually works. So, I mean, there we go. We have our first function contract call and our transaction history board is working. So now we're actually on a pretty good roll here. Let's go back up to our list group item and delete our placeholder near tokens and add some functionality to this. We can actually see the near tokens we want to display or the balance of the user. So let's call format inside curly braces, format output, which is the name of our custom function that we created earlier. Say format output, which will accept a windows.utils.format near amount. There we go. Inside format near amount, we're going to call a string just to ensure that the value of balance is indeed a string. And enter in balance with a lowercase b. And conclude all of our parentheses in our closing JSX tag or our closing curly brace. And you hit save. And actually, before you hit save, let's just add the word near next to this. If we go back to our application, let's see, format windows.utils.format near amount is not a function. Let's see, format near amount. Okay, we forgot one format. So it should be windows.utils.format near amount. And there we go. We have 153 near. And take note of this amount of here. So notice that we are just converting this from Yocto near to near, and then taking away any of these honestly unnecessary decimal places, because the user is not going to care about all of these decimal places. It's just going to care about these first 3, which is what's displayed on their wallet, plus maybe 2 more. And there we go. So now we've completed our send money feature. Let's head back over to app.js and see what else we have left on our list. So next we have our active keys feature, or active keys component. So let's go ahead and create a new file in our components folder for active keys. Let's call it active keys.js. Heading back to our app.js file, let's just skip some steps and import this new component we've just created. So import active keys from /components/active keys. So the goal, let's head back into here. So the goal for active keys component is to display our full access keys and our function call access keys on display in a neat, organized manner for our users to read. And this will also be a good way to kind of open up discussion about full access keys and function call access keys and what's the difference between the two. So let's type in rcsp as usual to kind of create our starting template. And let's import a container and a row from our React Bootstrap. And inside this div, let's just construct this out. So we're going to say container. Inside this container, we're going to call for a row. And of course, inside every row, we have our class name set to d-flex, justify content center. And let's go ahead and make another duplicate of this setup so you don't have to retype it. So duplicate that and put this on the next line. Inside this first row, we're going to create another component. We're going to place another component to call for now to say full access. And a placeholder for this one will be called function call. Let's see. Function call access. So hit save on that. Head back to our our application. And let's see, we have active keys here. Is this the correct tab? Let's refresh this. Oh, we have to save app.js. So let's save app.js. And we never actually called that component. So let's actually replace our placeholder with active keys. Self-closing tag, go back here. And there we go, we have full access and function call access. I missed my function, that's okay. So with that, we're going to create another subfolder inside of components. Let's create a new folder called active keys sub. Inside of active keys sub, we're going to create a new file called full access.js and another file which we'll call function call.js. And this would be a good place to start constructing our subcomponents to display the full access and function call access keys. So begin by using our handy template to create a function-based component. So if you type in rcsp, enter, you should have the template to begin developing a new function-based component. It will start by creating a state variable by typing in const full access keys, and the change method will be change keys, and we'll use state with the initial value for this variable being an empty array. So moving forward, after we have this set up, we're going to use the useEffect hook to begin developing our asynchronous function that'll be used to actually retrieve the keys from the blockchain. So using an arrow function to design our callback function, we can start development on our asynchronous function within it. So our asynchronous function would be async function with the name getKeys. And we're going to start off by defining two variables. So let key array is equal to await window.account.get access keys. So I'm gonna head over to the browser and show what the output of this looks like. So I actually have it right here. So this is what happens when you type in, let me just clear this out. If you type in await window.count.get access keys, what you're going to see is an array. Inside this array, you're going to have two types of keys. You're going to have a full access key like this one here. So you can tell it's full access because the permission quite literally says full access. And then down here, you'll see just a random key I just picked out. But down here, this is what a function call key would look like. So you open up permissions, you'll see this function call key has some sort of allowance, as well as the receiver ID for the contract that that this function key allows access to. So this allowance is cryptocurrency that's funded by the master account, allotted for this specific application. So that's the main difference between a function call key and a full access key. One will have access to your entire cryptocurrency storage, while this one will only have access to a portion of it. On top of that, it'll prompt the user anytime tokens are being sent out to another account. In contrast to the full access keys, which doesn't have to prompt the user after the user grants him access upon logging in. If you want a full description or in-depth description of these access keys, I'll put a link in the description to a video by Mike Purvis, who made a in-depth video for access keys on the Near blockchain. And you can go over to part 1 of this workshop series where I do a deeper dive into these full access keys and function call keys to go over the differences between them. So back to our application. These two variables we're going to define will be this key array to actually get the keys, and then this counter variable, which I will simply use to tally the keys and keep track of them, so we can actually display and output a counter onto our table. So now that we know that the output of the get access keys is simply an array of keys, I'm going to actually take advantage of that and use the map function to output some JSX into a variable, which will then replace the full access keys state variable up here. And I will show you guys what that means in a minute. So output array is equal to, let's do output array, is equal to key array dot map. Inside this map, I'm going to have a function where x will be each individual key, be it full access or function call access, and the second variable will just be the index. I don't actually think we'll need the index, but I kind of want to put it there just in case. If x.access key, underscore key dot permission is equal to full access, then we'll execute this function or this line of code. So we're going to say counter is equal to counter plus 1, and we'll return some JSX. So this JSX will simply be the design for the row that the keys will be displayed in. So what we're going to do is we're going to display the public key that corresponds to the private key of this full access key. So we're going to write tr, give this row a key. We set that key to counter. And inside this row, we're going to have a data block, so td, which will display the count. And we'll also have another data block that will display x.public key, the public key that corresponds to the full access private key. So now we have our JSX laid out, and we have the variable that's actually being outputted to. It's time to actually use this variable and use it to replace the value of this full access keys state variable, which is currently an empty array. So let's go ahead and do that. So let's see, below, here we go. So that's the map function, okay. So below, so after this get keys variable, we have to actually call get keys. So we're going to say, I'm sorry, my apologies. Actually, inside this function still, before we conclude it, we're going to say change keys. We'll change the value of full access keys to output array. Then after that, you have to still call get keys to actually activate this function. And we want to do all of this. So we want to do all of this upon the first occurrence instance at which the component loads onto the screen. So that's where we have this empty bracket here. And actually, to probably make it clear for you guys, we can actually just put this parentheses back up here to signify that this is the conclusion to the use effect hook. So now moving on to what we're actually going to display, and also we can still get rid of this prop type, so you don't really need that right now, as well as this line here. So what we're going to display is a table, so let's actually import that table. So import table from React Bootstrap. Inside this return statement, we will define the table as such. So table, striped, bordered, cover, variant is equal to dark. Inside this table, we're going to have the t head. Then the first row will have another th with the column span of 2 to stretch over multiple columns. And that will display our title, which is full access key pairs. And below that th, or t head, we're going to define our t body, so the body of our table, and write full access keys dot map, and x will simply return the value of x, meaning we're just going to return this JSX here. So remember that this JSX, So remember that this variable is simply an array of JSX now, where each individual item in this array will be these rows defined here. So this rows will display the count as well as the public key. So we're just spitting out all these rows into this table to then define and create a new row for each and every key that may exist. So this is the dynamic way of defining our tables, so we can actually show off our table to the user, no matter how many keys they have. So with that, let's save this, go back to our active keys, and import the full access JS file. So call it full access from / active keys sub / full access.js. Let's see what's going on. Okay. So async function get keys. I misspelled async. So let's go back over here. There we go. And let's replace our placeholder with the component we just imported. Make it a self-closing tag. Hit save. Go over to app.js. And let's make sure we actually have active keys called. Okay, we do. So with all this saved, let's just head back to our function and refresh and see what errors we have. So useState is not defined, that's an easy fix. Function access keys, yeah, it's not defined here. So usually when I type it, it gets defined, so I'm not really sure why I didn't do it this time, but that's okay. Okay, and there we go. Here are all of the public keys that correspond to the private keys of the full access key pairs. Nice and neat for the user to see. So now we're done with the full access key component. Let's move on to the function called key component, which is essentially going to be largely the same thing as the full access key component in terms of structure and design for the code. So let's just jump in and get started. So let's start with our handy dandy template. So our CSP, enter, get rid of prop types, and the second line here. Next thing we're going to do is create our initial state variable to hold the array of keys again. So const, and a state variable called function call keys with the change method called change keys, which will be set equal to useState with the initial value as an empty array again. Moving on, we will create our useEffect React hook, and let's just call useState here as well. And you know what? Before I even move on with writing out the useEffect, I think we can actually just go ahead and copy this entire useEffect from the full access key component and just change a few lines to save on some time. So the lines we're going to change are just going to be this conditional statement, where instead of specifically looking for keys that have the tag full access in the permission property, we're going to look for keys that do not have full access as the contents of the permission property. So because we're looking for function call keys now, so not full access keys. On top of that, instead of just displaying the public key, we're also going to display td the access key nonce. So what a nonce is essentially, let's just type this out, underscore key dot nonce. A nonce is essentially an instance, so it's a count of the number of times that the key has interacted with the blockchain. It's used just to make sure that each interaction is unique and different and separate from the last one, so we don't have any repeated interactions. And past this, we're also going to go back to our sendTokens.js key or component and copy over this format output function, because the next thing I want to write or display in our function called key component will be the allowance that is allotted for that specific function called key. And to do that, I want to actually format it in a readable way. And to do that, again, format it from Yocto to near, we'll also have a lot of digits past the decimal place. So I want to get rid of most of those digits and just be left with 2. So td, we will call for windows.utils.format near amount, and then we'll say x.access key dot permission dot function call dot allowance, and so we're gonna have that formatted amount, and around this entire thing we just wrote, we're going to call our format output function. So format output so let's make sure everything looks good. Here we are. Okay, so I see no red lines here, so it seems like we typed everything out correctly so far. But we'll find out when we actually execute this thing and see if we have any errors. But for now, I think we can safely assume this is written correctly. So essentially what this is going to do is, once we get our, let's see, So wait window dot account dot get access keys. So essentially, once we find a function call key, that's a full access one. Let's find function call somewhere. There we go. It works. So we're going to go into access key, then after that we'll go into permission. Then after that we'll go into function call and call the allowance property of the function call to see how many near tokens we have allotted to this specific key, and then format this into from Yocto near to near, and then simply cut off the trailing digits that will make it harder to read. So that's what essentially we're doing here. So now so I think that's essentially everything we need to do for the use effect. So let's go down over to the return statement and just lay out the design for our table. So we're going to call table from React Bootstraps. Actually, let's import that. So import table from React Bootstrap. Inside of table, we'll saythead, tr, and th to denote the name of this table. You will span this header over 4 columns. So column span. So each of these is a column, the 4 TDs. And this will be called function call key pairs. Below thead, we're going to define our tbody. For the first row, let's see, here we go. So the first row, we will have our first entry be an empty header, so just a blank header, just as a space holder. And then next will be th, which will be the public key pairs. The next will be another th to note the nonces. So nonce. Then the next header will be the allowance. So say allowance. Actually, let's switch this from tbody to thead again. So we'll replace these with thead. There we go. And then below this thead, we'll have our tbody. And this tbody will simply just be the output of this function call keys array using the map function. We're just going to return each of these individual rows that we have designed here. So again, this is just an array of JSX and returning each individual JSX block. So function call keys dot map x return x. So we're gonna hit save. I don't think we have any errors, so let's go back to active keys and import this function call component. So function call from dot slash active key sub slash function call dot js. Hit save again. Replace our placeholder with this new component. Self-closing tag. Hit save. And go back to our browser. Let's see if we have any errors. We have a few errors. Let's see. Function call keys is not defined. So let's go back to function call. Online it says 69. Okay, I misspelled function up here. So let's replace that with a T. There we go. And change keys is not defined. Where is that? That is on line 42. And change keys, is that really not defined? Oh, it has a capital C, so let's change this to a lowercase c because I kind of like camel case a little better. Here we are. So we have our full access key pairs, and below that we should have our function call key pairs. Let's modify the variant of that table. Actually, let's go back to full access key and just kind of copy this line here and paste it over the table that exists here. Hit save again, and that should go from white to black here. There we go. Nice. So, I mean, there we have it. We have our data table, our metadata table, our feature to be able to send money to a friend, as well as record the balance, our total function key pairs table, and our function call key pairs table, as well as that displays our public keys, our nonces, and our allowances. And you can see that our allowances are formatted correctly into something nice and readable. So there are a few more styling components I want to kind of like knock out of the way, just to make everything look a little bit cleaner and nicer. So I want to increase the spacing between this balance block and this send money block, as well as the spacing between this function key pairs. And then after that, I want to change the background color of this entire thing, just to make everything pop out and stand out a little bit more. So let's start off with the send money feature. So send money feature, we have two cards that are separated by these like two containers. So let's just say, let's say for this row, let's just increase the margin up top, just to kind of increase that spacing between. Just as use inline styling. So style is equal to 2 curly braces. We're going to say margin top and set that spacing to 20 px. Feel free to change this as you wish. I'm going to use this again for the function call key. So for the full access key block. So let's just copy this and so we don't have to retype it. So hit save and go over to activekeys.js, and inside this div, let's add the same thing. So style is equal to margin top 20 px. And then as for the background color, let's go to appstyles.scss, and above this line here, this import statement, we're going to write we're going to modify one of the variables within the SCSS file for Bootstrap. So we're going to say $body
I'm about to catch a body in here, baby.
-bg, which stands for background, and change that background color to RGB 39, 39, 39, and hover over this little box here and click on this RGB 393939, and let's change it over to hexadecimal, just so it's readable on multiple browsers, and conclude it with a semicolon. So we're going to hit save and go back to our application, and there we have it. We have some nice spacing in between the send money box and the balance box, as well as some nice spacing in between the access keys and our send money feature. And there we have it. We can log out, see this notification for the user to log in. Let's get rid of this inspection tool. So requesting full access to an account, so now you guys know how to do that. I'm going to log in with BlockHeads.testnet. And once we log in, we can see the amount of near tokens I have in the octo near, the lock tokens, we can see we have no contract deployed to this account, see how much storage I've used, storage I paid, the current block height, or the block height which this account exists, and the block hash, as well as the more nicely formatted balance, and a feature to send any user more or less, more money. So I can say blockshop.testnet, which is an account I created for another video, and send them 7 near, hit submit, open up a terminal, and we can see this little notification here from our contract as well as a receipt showing that we've actually sent them 7 near. So if we refresh the page, you can see our balance go down, and you can even see our total transaction history with blockshop.testnet. So now you guys should know how to wire up and route your contract calls and know the difference between change method and view method. And now we can even see and display all of our public keys and how many public keys we have for this account, 2 separate third-party applications, as well as a function called key pairs, showing their respective allowances and the knots that each public key is currently at. So great job, guys. You guys did very awesome in working through this application with me. Hey everyone, thank you so much for watching this video. I hope you guys enjoyed it. I hope this video plays a helpful role in your development in creating some really cool blockchain applications. I hope one day I get to see what you guys create. If there's anything I should improve upon, if there's anything I should go into more detail about, or if you just have any general questions, let me know in the comments below and I'll do my best to get back to you as soon as I can. Like, subscribe, and share with your friends. That really helps me out and I'd really appreciate that. And guys, keep growing, keep learning, and have a great day. Thank you for watching.
Where to first?
Your mother's butt.
I'm so alone.